Welcome. Today we're going to be starting our conversation on the ecology of barrier islands. In this presentation, we're going to be focusing on the intertidal zone and the sand dune ecology. So for barrier islands, we're going to focus on the mid-Atlantic barrier islands. Those are the ones that are very close to us, although you can find these barrier islands in similar ecology all along the Atlantic shoreboard and even the Gulf of Mexico. So what are barrier islands? Barrier islands are long, narrow, offshore deposits of sand or sediment that are going to run parallel to the coastline. So you can see that here. This would be the Atlantic Ocean, and this is the barrier island. They are going to be separated by something from the mainland. So it might be a shallow sound or bay or lagoon. You can even have inlets that are going to be separating them from the mainland. So on this side, you would find the bay or the lagoon, and then the inlets then would actually form that final separation to create these barrier islands. So for barrier islands, you're going to find very similar layouts. You are going to have the ocean side, then you are going to have the beach that faces the ocean side. The beaches eventually then will give way to dunes, and through a series of succession, you then are going to form your mature dunes, which are going to be those forested areas on the island. And then on the back side, you have your salt marsh area and then your open body source, so lagoon, bay. The other interesting thing about these barrier islands is that if you were to look on, let's say, this front side of the island and you were to dig down deep enough into the beach, you would find old remnants of marsh systems. Because barrier islands do have that rollover towards the mainland, you're going to find different species in a preserved nature if you were to go down far enough. So again, you have your ocean, you have the barrier island, and then you have your water source on the opposite side. So in this case, the estuary, but it could be a bay or a lagoon. We're going to focus then on the first part on this beach and the salt marsh area. So we're going to focus on the region that the water actually will come up on either side. And that is called the littoral zone. So the littoral zone is the area between the mean high tide and mean low tide. And there's going to be one on the ocean side and one on the bay side of the barrier island. So another name for it is called the littoral zone, the area of which the water is going to be moving from high to low tide. The littoral zone, again, is going to be between the high and low tide, but if you go below that, then that's the sublittoral zone to the ocean. And then if you go above that on both the bay and the dune side, it is the supralittoral zone. How do they form? Well, they form because of that interaction of the tides moving in and out of the area. The ocean side is going to have a higher wave energy from the force that the waves have coming in. They also then on the ocean side have a larger particle size. Those particles are not going to be weathered as much on the back side of the island because of that long short current. It's going to pull them across and it's not going to keep them in one spot like it might on the back side. And then again, because of that, you're not going to have a whole lot of organisms that can act as decomposers. So you also will have lower nutrient levels. On the bay side, it has the opposite. So it has lower wave energy, it has smaller soil particle size, and it's going to have higher levels of nutrients. These stresses then that have to be accounted for the adaptations of the organisms. You're going to have a more constant change in temperature, salinity, moisture, sunlight, and oxygen. So these then have to be accounted for through the adaptations that the organisms have that live in that area. Because of high and low tide, all of those variables will change throughout the day. because you also have that wave energy and then the wind energy then that's going to cause those waves, you also have to have an adaptation for dealing with that wind and the abrasion from the sand being carried by the wind. Predation. So you're going to have survival strategies that you can maybe camouflage or dig down so that you can avoid being eaten if you are exposed during low tide. Desiccation. So again, you are going to have to be without water for a while. So you have to have those adaptations that will allow for you to have that. Wave shock, kind of hand in hand with the abrasion. And then waste removal. Oftentimes, organisms are going to have one way that they can remove waste, and depending on where they live, either in dry areas or in water, or I guess like you and me, we're going to get rid of our waste in a method for one of those. But if you have water sometimes and you don't have water sometimes, again, those are adaptations that need to be considered. So some of the adaptations then, for abrasion, they have hard coverings. So they have these shells or exoskeletons that are going to prevent them from being damaged. Most of them have some type of burrowing ability so that they can get into the sand where moisture levels are going to remain pretty constant. They're not going to be exposed as much to waves and wind, and then predation as well. They're going to have some type of means for attaching. So they're going to have something that's going to keep them in that spot rather than being taken in and out with the tides. That might be tubes. So like these tube worms over here, they're going to have their homes that are going to be attached in one spot so that they can prevent them from being taken up by the tides. They might be able to just seal themselves within their exoskeleton. So the operculum, they might be able to kind of seal off then an exposure to keep their moisture levels constant. They are maybe just adapted to going with the flow and being able to go with and against the tide, and kind of like a plankton, just be able to move with the current. They also then might have light exterior to reflect light, and that's going to help to keep them from overheating. And it also might allow for them to better camouflage in with their environment. And gills in a chamber. So again, they could close off that chamber that would allow for them to maintain their moisture level so that they could exchange oxygen with the air around them. So different types of organisms, both the flora, the plants, and the fauna, the animals, you're going to find on either the ocean or the bay side. On the ocean side, you tend to find more like crabs, mole crabs, 5 keyhole sea urchins, which are your sand dollars, starfish. On the bay side, you're going to find more snails and worms and different types of crabs, oysters, mussels that are going to require those higher nutrient levels and less stressors. Ones that you're going to find in both areas, you're going to find clams. Clams are pretty resilient. Definitely different types of algae, phytoplankton, zooplankton, sea lettuce, anemones, barnacles, hydroids, minnows, crabs. So you do find them on both of those areas. And then birds. So birds are going to have adaptations, and if they have adaptations for one side, they tend to have them for both sides. They tend to have these longer beaks, longer legs to allow for them to wade in water. So birds like this, like egrets or herons, cormorants, terns, oyster catchers, gulls, and sanderlings. A few examples. Here's your mole crab or sand crab, as you may have dug for these crabs going to even Delaware or Jersey beaches. Here's your sand dollar, your 5 keyhole sea urchin, fiddler crabs, the cormorant, oyster catchers, egrets, great egret. For the fauna as well, depending on the adaptations that they have, you can either have your infauna, which are ones that will then burrow down, or your epifauna, which live above then that water surface. For all of these, then we'll also relate them back to what they do, so their ecological significance for that barrier island. So for the intertidal zones, it's going to help prevent the soil erosion. So if you have organisms living within this area, it's going to help to hang on to the sediment. So remember, a lot of them have adaptations where they kind of keep themselves in one spot, and that also helps to keep the island maintaining its structure for longer periods of time. Because you have these fauna, you're going to also act as a buffer for mainland storms on the backside of the island. They're going to be a breeding ground for a lot of different organisms. So you may have heard of like the horseshoe crabs, the Delaware beaches, but they're going to use that littoral zone for their breeding. Sea turtles, and you may have seen, videos of this where they dig their holes right along the shoreline, and then the baby turtles will hatch and move their way into the water. Recreation, if you've ever gone to the beach, that's a littoral zone. I mean, think about moving your chairs for high tide or low tide. That is something that we all like to be in. And then for the different organisms that live here, they can have different types of strategies. So an R strategy versus a K strategy. The R strategy, that's going to be more of your oysters and clams. These are going to be organisms in which most of them that are going to be born or their eggs produced are not going to make it until adulthood. So there's going to be a high level of death as soon as they are formed. Whereas your K selected species, these are more like your birds or you. They are going to have a higher means of mortality later on in life. So they're not going to be producing as many offspring. But hand in hand, they're definitely going to influence each other. So if there's not enough of the R selective species, there cannot be enough of the K selected species. All right, next is the sand dunes. Sand dunes, and you, again, if you've ever gone to the beach, may have seen sand dunes, and you may have seen these seagrasses then that are going to be growing on the sand dunes. But sand dunes have levels at which they are going to evolve. So they are going to, and you can notice these levels of succession. So to form a sand dune, it does follow this ecological succession process, and this is just a change of communities over time. So you're going to have your pioneer species that are going to start establishing your sand dunes, and then over time it's going to create these mature dunes. And again, because these islands are continually rolling over, this is a continual process. And more or less, it does follow a predictable pattern at which you're going to see different organisms living in different areas on the island based on where ecologically it is. So to start, it does depend on the littoral zone. That the waves action of high tide are going to be depositing what's known as a tidal rack. This is going to be different types of organic debris. So this is oftentimes like seaweed that you're going to see wash up on the ocean or the beach from the ocean. But it could also be remains of other plants and animals, and that forms what's known as a strand line right along the surface. And then over time, when the wave and wind action brings sand on the shore, it's going to allow for moisture to be retained. If you have this organic debris underneath of the sand, temperature is going to be much more stabilized within that dune than right against the ocean. You're going to be able to start to build up nutrients because decomposers can feed off of that organic matter. And then eventually you might have conditions in which there's going to be enough soil and enough nutrients for other plants to actually start a germination process and grow. So here's an example of a strand line that has washed ashore. The first species then that are going to start to grow once that strand line has been covered with sand are known as your pioneer species. Two primary pioneer species are the mid-Atlantic barrier islands, or the sea rocket and Russian thistle. So these species are hardy. They do not require much soil, do not require much nutrients. And they can they do have lots of adaptations for maintaining their moisture concentration, and just growing in really horrible quality soil. And through their process of just interacting with the soil that they're growing in, they tend to improve that soil from horrible to poor. Next, you have your cereal communities. These then are going to be ones of typically I feel like these grasses, these American dune grasses that you might see on a sand dune. But they can also include sandspur, goldenrod, and these of those, the American dune grass is going to be the most important. It does tend to get outcompeted by an invasive species called Phragmites. So that's something that is something to look out for. It's going to do a better job of growing and using nutrients. But if the American dune grass isn't able to grow, then the dunes have a harder time going through the succession process. The American dune grass, in comparison, is going to have a better root system to help hold that dune together. So not only does it have the tap root that goes down so it can reach that water table for fresh water, but it also then has those roots that can grow sideways or horizontally, and that's going to allow for that stability of the dune. They also then, with their roots, have rhizomes, which are going to be bacteria that are going to just help that root system take hold. The rhizomes also then are going to branch out horizontally, that are going to grow clones of that initial plant. But again, all of this is just going to help hold that dune in place. And eventually the embryo dune is going to form thanks to these cereal community species. And once you have your primary species in place, you can then allow for this ecological succession to continue. Wind is going to carry with it sand, and that sand is going to continue to accumulate, and the soil itself is going to become better in quality, allowing for succession. So again, the American dune grass, in addition to the taproot, has a fibrous root system, and just other adaptations itself. It's going to have a really thick epidermis. It's going to allow for it to withstand that sand abrasion. And think of it like a snow fence. So it's going to allow for that sand to stay in one spot instead of drift all over the barrier island. So you have your dunes that build up. You have your embryo dune, which will transition to a foredune. That foredune is going to then go through a series of succession, where it eventually will become a climax mature dune community. You may also realize that there are areas on the backside of dunes where they can have some dune slack, and you can have some water that might accumulate because it's beneath that water table. So other things that will continue to improve the soil conditions, you're going to have different organisms moving in. So the bayberry and the beach pea are going to carry with them other types of bacteria that are going to take the nitrogen from the air and convert it into nitrogen that plants can use. So NH3 is pneumonia, and that's going to be one that plants can take up then through their root system and use to make those organic compounds. Eventually, the dune is going to grow in size where it will block that salt spray from the ocean, allowing for small shrubs and even trees to start to grow. And then eventually you form a climax community. And this is going to form a maritime forest, which we'll talk about a little bit later. But that's going to be composed of different species. So primarily on barrier islands, they're going to have these loblolly pines. These can grow really fast and they will quickly shade out their competition so that they have access then to the resources. But the advantage of this loblolly, besides its fast growth, is that it has a very flexible stem. So it's got a lot of leaves right at the top, not a lot at the bottom. So this is oftentimes used for telephone poles. And then as the needles drop, they are acidic, so that's going to deter several different species from growing in that area. But at this point, at the climax community, it is a self-sustaining community. It's going to have adaptations that will cycle into the matter that can be passed from one species to the next. Stresses on the dune system: erosion from wind and water. Fresh water is also a stressor because they don't have access to it unless they have those tap roots that can reach it. Wind abrasion, salinity from the salt spray, and then, of course, predators. So the adaptations that they have the fibrous root system that run horizontally. A lot of them, the flora have tap roots. The fauna then have the exoskeletons or some type of shell covering, thick epidermis if it is a plant, and grass growing when covered. So when those dunes have grass growing on top of them, again, the grass acts like a snow fence. It's going to help to prevent some of those stressors. Different types of flora that are there: the American dune grass, sea rocket, which is this, beach pea, sandspur, and a bayberry bush. Some of the fauna, you have different types of beetles: ghost crab, fox, deer, horse flies, green head fly, and ant lions. Ant lions was actually in the Marshmallow Madness competition from last year, and I have a video of what an ant lion does in the dunes. So I think I'm going to play that for you now.
This is a story about crafty, fearsome lions. Oh, not this kind of lion. This kind of lion. You're looking at the predatory larva of the ant lion. This creature can remain in the larval stage for up to 3 years. Like the big cats, this specimen is in Africa, although ant lion species can be found in warm regions around the world. These lions have ferocious jaws. Only these jaws are hollow, allowing it to suck the life juices out of, what else? Ants, or whatever it can trap. The sand has to be just right, fine-grained, soft, for this crafty critter to rig a trap that will make catching a meal a slam dunk. The antlion makes like a steam shovel, lobbing the sand and pebbles out of the pit. He burrows into the bottom, ready to use those awesome choppers on whatever bumbles into this ambush. Sure enough, an ant slips into his ditch. It tries to escape, but the antlion larva doesn't give up that easily. He pummels the ant with sand just as it's about to get out of there. No matter what the ant does, it's doomed to slide back into the jaws of death. The larval antlion may be a heck of a lot smaller than its namesake, but it is every bit the voracious predator.
Did not win the competition, but I think he definitely won a few battles. So that's one of the species that you can find on a dune. And then the last part, again, what is the ecological significance of dunes? They're going to absolutely protect the coastline. They are valuable to prevent a lot of the sand from being taken away by that longshore current. Because of those horizontal roots, the rhizoids that they have, they can help prevent erosion of that barrier island. Islands are not going to stay in one spot forever, and they do roll over towards the mainland. But without dunes, you're also then going to lose a lot of that sand on the front end of the island. They're a valuable habitat for lots of different species, especially shorebirds. So these are going to be migrating birds, and they need dunes to be able to lay their nest so that they can continue their case selection and that they can continue their life cycle. It's also important that you take note and that you funnel or help to funnel traffic to protect these dunes. So, oftentimes, beach communities now will have walkways between the dunes so that you're not walking on top of the dunes. And this then will help prevent the tragedy of the commons. So if you think about these dunes look like they'd be fun to play on, so think about what they actually do and why they're valuable. So the tragedy of the commons is where you have this common ground and where things are living below carrying capacity. So all can benefit from this ground or from this dune if we allow for that community to flourish and we don't take advantage of that community. But if we use the dunes and then it makes it so that the community is above or beyond its carrying capacity, or we destroy it so it cannot has a lower carrying capacity, then eventually what would happen to it is that it's just non-existent and that land cannot provide like it once did. So you are accountable for your actions and to make sure that we do sustain those dune ecosystems. That is all for today. Next week, we'll have a part two where we're going to be talking about the salt marsh, the bay region, and maritime forest. If you have any questions, please let me know. Have a wonderful day.